we're going to go over some factoring using the greatest common factor. Now, I did go over these yesterday. I'm just going to do like number 5, then I'll mosey on down to the bottom half and do a couple from down there just to give you some help. I will be posting another video in a little bit about factoring, so you can work on this worksheet and the factoring of trinomials worksheets today and ask some questions. And this will lead nicely into what we're going to be doing next week and the week after, which are quadratics and probably some radical stuff too, square roots. Now, first things first, this one right here, number 5 is the one I'm going to do first. 5x squared plus 10x. You first look at the coefficients. Is there a greatest common factor for the coefficients? Is there something that divides into both of them evenly? Yes, there is a 5. Now, you also have to look at the variable parts. Is there a common variable? And how many of them are there that are common? This one has 2, this one has 1. You need at least 1 in each one of them to be able to factor out the x value in this one. Okay, and it is an x to the first. You don't need to put a 1 for the x to the first, but it doesn't hurt anybody. Dividing 5 by 5, you're left with 1. Dividing x by x, you're left with just the 1x there. Okay, divide 10 by 5, and then you're left with a 2, and you divide the x by the x, it cancels out, and you're left with just this. Okay, you don't need the 1s there. They're just there for giving you a better look of this. And you don't even need the 1 here, really. It just shows it. This would have been sufficient, and that's usually what regular math teachers will show you. But it doesn't kill anyone. There will be teachers that don't put a 1 there. Okay, don't put a 1 there if they don't like it, but it's not hurting anybody. Okay, 5x to the first times the quantity of 1x to the first plus 2. 5 times 1 is 5, x times x is x squared. 5 times 2 is 10, x times 2 is x up there. Okay, now if you look down at number 7, you don't see a coefficient that can be factored out. The 3 and the 7 are prime numbers. They can't be factored. So in this case, all you can factor out is a variable. So that will happen sometimes. That will happen. Now, let's look at number 10. Number 10 is what they call here, a little more difficult problem. I just wrote on my computer with this marker. Nice. This is a little more difficult problem. 12x to the third y to the second. I don't like the way this is written, but 12x to the third y to the second plus 18x to y to the fourth. All right. Don't worry about the variables yet. Let's worry about just the coefficient, 12 and 18. 12 and 18 are both divisible by 2. They're both divisible by 3. They're both divisible by 4, 6. And I think that's good enough. Okay. 6 is the greatest common factor. Okay. So if I can factor a 6 out of this, 12 divided by 6 is 2. And 18 divided by 6 is 3. Okay, I factor the 6 out. So I'm done with the coefficients. These guys are done. Now I've got to look. What is the most amount of x's that I can take away from both of them equally? Okay, this one has 3 x's. This one has 1 x. So the most I can take away from both of them evenly is just 1 x. How many am I left with here? X to the second. Okay, how many x's am I left with here? None. They cancel out. So the x's are taken care of. I factored out the most that I could factor out. Now the y's, I can take 2 y's away from both of them evenly. Okay, 2 y's is the most I can take away from both of them evenly. That's wiped out. I'm left with no y's. You do not write y to the 0 power. Y to the 0 power is just 1. It doesn't matter. It doesn't affect anything. You will get teachers that go a little ballistic if you put an answer of y to the 0 power down. I wouldn't go ballistic, but I probably would say, don't put y to the 0. It's unnecessary. It's like multiplying by 1. You don't need to show it. Okay, but you take away 2 y's there, you're left with 2 y's. This is the final answer. 6xy to the second times the quantity of 2x to the second plus 3y to the second. That is the final answer. you could test it to make sure. 6 times 2 is 12. X times x squared is x to the third. Y squared times blank is y squared. 6 times 3 is 18. X times blank is x. Y squared times y squared is y to the fourth. So this does work out beautifully. Now to look at the factoring problems down at the bottom of the page. The factoring problems down there deal with the beginnings of quadratics. Okay, they say solve by factoring. This is the beginnings of a quadratic type of problem. Okay, but let me show you what it means. Let's do number 13 and see if that helps you do the rest of them. 5x to the second minus 30x is equal to 0. How do I solve that? Instead of guess and check what x could possibly be, you can solve this algebraically. How? Watch. What is the coefficient GCF, greatest common factor? It is 5. And can you take away x's from? Yep, you can take an x away times the quantity of x minus 6. All is equal to 0. Now, this still looks like you're going to have to plug and chug, plug an x, but watch. You can find that there are actually not just one answer here, there are 2 answers that could possibly be put into this that would make this statement true, equal to 0. You can write 5x equals 0, and then take the other part, x minus 6 is equal to 0, and solve both of those equations to find both answers that can be used. Divide by 5. X is equal to 0. 0 divided by anything is 0. Okay, so that's a simple one. And over here, add 6, and x could equal 6. Either one of those 2 answers, x is equal to 0 or x is equal to 6, both of them would work in this. How do I say that? Well, let's do it. Put the 0 in for the x. 0 squared is 0. 0 times 5 is 0. Negative 30 times 0 is 0. 0 minus 0 is 0. It worked. Let's check the 6. 6 squared. Okay, 6 squared is 36. Okay, 36 times 5 is 180. 30 times 6 is 180. 180 minus 180, guess what it equals? 0. So either of these 2 answers could be placed in for the x and make it a true statement. There are 2 answers. Now, algebraic equations up until now, you've only been able to find an answer unless it was an inequality. And then you found multiple. But these, you're finding sets of answers. That's why set each factor. That's why these are sets, solution sets. Okay, you'll hear teachers say that. All of the rest of these on this page are very similar to the one that I just did, okay? You're going to be able to factor something out and a variable. Factor something out plus a variable. Factor something out and a variable. Oops, my computer just moved on us here. Every one of them works very similarly to this. Alrighty, if you have any questions on factoring with GCF, send me an email. I'll help you as much as I can. I hope this helped. Talk to you soon. Coming up next is going to be factoring trinomials. Yay. Bye.